Hello and welcome back to Welding, Chapter 13. We're going to start into shielded metal arc welding practice jobs. Your objectives. Let's start into the introduction. I'm going to read from the book, page 340. Introduction. Practice in shielded metal arc welding, also called stick electrode welding, is a basis for learning the other types of welding. SMAW accounts for less than 50% of the total amount of welding being done, while gas metal arc welding and flux core arc welding make up over 50% of the welding being done. Submerged arc welding follows with less than 10% in popularity. Stick welding has great versatility. It's a dependable process that welds any steel in any position. It's readily available and modest cost. It will probably be used as long as any type of welding is being done, and especially in maintenance and repair work. This is still true today. There are tremendous advancements within filler metals. We have come a long way in the last 10 years as far as technology goes. Machines are, a more advanced welding machine is also more affordable than it used to be 10, 15 years ago, along with now we can put alloying elements within filler metals that we weren't able to before. For example, I've TIG welded with a flux core stainless steel electrode filler metal. 5 years ago, I don't think that was even heard of. So, common way to, especially in an outside atmosphere, you can put a stainless steel TIG root pass in with an internal shielding of the flux plus the external shielding of the gas, and it's a little more friendly for a high quality weld in an outside atmosphere. So this is very true, and for most shop owners that I talk to, most people that I know say if you can weld shielded metal arc welding good and efficiently and effectively, then usually you do not have a problem with wire and flux core. However, if you've only learned how to weld gas metal arc welding and flux core arc welding, a lot of times it's a very different welding process to switch over to shielded metal arc welding. You may not need it a lot, but when you do need it, it's usually you're out in the middle of nowhere on a service call 300 or 400 miles away, don't have the material, and if you can weld with shielded metal arc welding or stick electrodes, you can usually get the job done fairly well and be productive and finish up on the job. Let's go to the bottom of that page, 340. The last sentence is the one that I want to focus on. Let's look at that last two sentences. The jobs in this chapter provide practice on a number of fundamental joints and welds. Here's the bulleted point, okay? Welded joints include the edge, lap, T joint. In this case, there's the three. There's only 5 weld joints total. It's the edge, lap, T, corner, and butt joints. The five joints is all. You will learn how to run stringer and weed beads and make fillet welds in the flat, horizontal, and vertical positions. Depending on which point this chapter is in, or which course it's in, you may have been past the flatter horizontal, but you may not be at the vertical position yet. So let's talk about these jobs and keep going forward through the chapter. I want to stop at this PowerPoint real quick. It's the next one that we're going to talk about anyway. Approach the job. We can read out of the book, but here's the main thing right here. This right here is by far the most important piece. And when we're starting anything for the first time, we're hardly relaxed. We're usually tense, we're nervous, we want to do well. Most of the time we want to feel like we come to it naturally, or we've done a little bit of it and we think we're doing really well, but we're still nervous, okay? There's no need to be nervous whatsoever. Most of you have met me by this point. Hopefully you've been comfortable with me. As you know, I'm here to help you improve. I started out welding for the first time. Everybody started out welding for the first time. Nobody just jumped in and knew how to do it. Some people pick it up more naturally than others do, but they still had to practice. I don't care who they were, they still had a lot of practice to do. And especially to be able to do it day after day, you know, multiple welds, 100 welds a day or 30 welds a day, whatever. And keep moving forward. I mean, you're welding all day, I wouldn't say all day, but you're welding most of the day, moving forward. It takes practice to get there. And we'll get there. We'll get there. But if you can do this, if you can learn to relax, 90% of it is just that alone. You have to be comfortable, okay? And there's also a point in time to where you have to not be too relaxed as well, okay? So for example, when I'm doing code quality welds, I'm a little more on edge. By the time you're getting to vertical and horizontal and overhead positions, I'm a lot more aware of watching my sides and so forth, because now I'm defying gravity as I'm pushing the weld bead up. So for example, one of the things that happens when you're out there welding a long time is you put your welding hood down, and then you start thinking about what you got going on at home. Are you gonna, you know, what's your paycheck look like? What's your spouse or your children doing, or your significant other? You got everything in life that a lot of times you put the welding hood down and you're thinking about that, okay? What you're gonna do for the weekend and so forth. But when I put my welding hood down, I try to make it a conscious effort, especially if I'm gonna be doing a code quality weld, that I make sure that I'm focused on my welding and not something else. And sometimes in order to do that, I will physically tell myself as I'm welding, if I'm going up the weld, I'll say tying in, tying in. I will verbally talk to myself, and especially until I get the pattern down, okay? I may go 1, 2, 1, 2, 1, 2, whatever technique has worked for me, what I've caught on to. Again, there's many different styles and ways to weld. Hopefully at this point you have latched onto something that works for you. Doesn't mean it's going to be the only thing that works for you. There's more than one way to do this. I've seen a lot of very talented welders and very many different techniques. Now, what I will do is if I go in there and I watch you doing a technique, I may point out something that I don't necessarily understand. I may point out a reason why. I might tell you, well, you have to be careful of doing that technique because what's happening is you're walking away from the puddle too long and you're letting it solidify, so you might be catching slag within inside of that weld puddle, or lack of fusion on one side or something else, okay? Doesn't mean that it's the wrong way, but I may come in and have a discussion with you about it as well. Gripping the electrode holder lightly. I mean, this is all part of being relaxed, okay? Now this is one that I don't necessarily agree with. I've done it, and I still do it sometimes, occasionally. But the one thing that I want to really make sure of is that you're not wrapping stuff around your body, okay? And I'll tell you why this is a safety issue, but even if nothing were to happen, you're also creating a magnetic coil around your body, okay? But the welding leads can get hot, they can catch nicks, they can start on fire, they can burn you from melting, they can also restrict you from getting out of somewhere if you need to in a hurry, okay? We're dealing with molten metal at 5,000 to 8,000 degrees roughly. Things can happen very, very fast on a safety standpoint. You need to make sure that you're not restricted by your welding leads, okay? And then that goes for your body harnesses as well. You know, I've done a ton of confined space entry welding with exhaust fans, exiting, and positive fans. Been in tanks and so forth. And before I strike an arc, I will make sure that I check around. I've got my lifeline, usually somebody on the outside holding me, making sure that if I were to pass out or something, they can drag me out. But I also make sure that nothing's in my way. I would purposely route stuff around to where if I had to leave in a hurry, I could. And if you've been through the orientation with me, you'll understand why. I've probably told you the story about my father being blown up as well and spending time in the burn center because procedures weren't followed, okay? So I always think about myself. You know, my father was also a good example of this. He would wrap that lead around his arms, and he never realized, but he would end up with these deep bone bruises as well. And one day he was welding with an older gentleman that helped teach him how to weld when he was younger. And he told him, don't do that, you know, you'll create issues. And sure enough, as my dad was progressing more and more through his career, he would find the days that he would wrap that lead around his arm in order to help stabilize or keep it secured up, he would go home and his arms would be really, really sore, like a deep bone bruise on the inside, all the muscles as well. So be careful of this. Make sure you always maintain and use the proper protective equipment. Okay? The number one thing is right there. Be relaxed. Okay? Also, keep your welding hood clean. Proper shade, properly adjusted. Keeping it clean is a big part. If you cannot see this puddle, if you cannot see the weld puddle, it's going to make it very difficult for you to weld. Okay? You can be nervous, but you still have to be able to see the weld puddle. We're watching the puddle, not necessarily the electrode or where it's going. So many people get so confused with it. Everything's starting out and it's going really fast, and you're out here watching where you're going and ahead of, when you actually need to be focused on the freeze point, the back side of your circle, as you're welding along. Okay? So let's talk about this. If this is my welding electrode here, okay, here I'm welding along, I want to be focusing on this back side of this weld puddle where it's freezing, specifically on this back portion. I want to make sure it's a nice round shape. If I have a shape that looks like this, then that means my travel speed's too fast, okay? If I've got a V-shaped weld. If my weld pattern looks more like this, and my slag is starting to roll in front of me, and I'm fighting being able to see my weld on the leading edge here, then I know that possibly I'm going too slow as well, okay? Keep my rod angle back, and I want to look for this nice rounded bead as we're welding along, okay? This is specific to 7018, we're just dragging it along. 6010, we are going to talk about what we're looking for. So when we're welding 6010, we're going to strike our arc. Okay, we want to strike it like a wooden match, get it going, and we're going to stop and we're going to let it pause. We want it to get about 2 times the size of the electrode. Now, my drawing won't be to scale, but I'm making it to where we can see this on the camera. Okay, but I want my weld puddle to grow this big. Okay, my welding electrode is going to be about here towards the leading edge. Okay. About 1/3 of the way in, I guess. And I want to watch back here. I want to make sure that it's a nice round shape. I'm going to be focusing from here to here, because that's my freeze point, and that's where all of my discontinuities are going to solidify as well. Okay? Now, on 6010 5P, we started out dragging, and now we're starting that whip and pause technique. Okay? So I want you to come out, and we're not going to pause here. If we pause on this side, then we're depositing weld here, and then we're going to come back and we're eventually going to have to weld back over this. So when I whip and pause, this is a very fast technique. Okay, I want to come out, back in. And when I come out, my eyes, I don't want to watch this welding electrode go out here. I want my focus to go right here every time. I want to find the toe of the weld I just left. So I come out, I look here, and I come back. I'm going to pause here. Out. Find here with my vision. Come back. Out, find here with my vision, come back. Starting to see the pattern? Okay, so let's do this. Let's erase the pieces that we welded over. And now look what we have. We have a stack of nickels laying on top of each other. We have a nice even bead pattern going along. So that's our aiming point, okay? That's going to help with our consistency. In order to be consistent and a nice weld appearance, we have to have some sort of repeatability or a pattern, so to say. So we need to come out, back to the toe, out, back to the toe. so that we get that nice uniform pattern within it. Okay. Moving on. Polarity, we've talked about this, so DC electrode positive. In this case, the electrode lead becomes positive side of the circuit and produces the deepest penetrating weld. Electrode negative, so real quick, electrode positive is what we're going to be very common with a 6010 or a 7018. We want to have good penetration. It's going to be a very hot process as well. Okay, so more heat is being applied to the base metal or the workpiece. Now DC to electronegative, this is more familiar with the gas tungsten arc welding, so TIG. So a lot of times we're welding a very thin piece. So in this case, we don't want as much heat being applied to our material. We want to make sure that we are tying in good, but we're not putting a large amount or a high deposition rate down. Okay, not a large amount of metal. So very thin bead, but it's of a high quality value. We can see the weld and so forth. So electrode negative, we also talked about the negative is a straight bar, so it's straight polarity, correct? The electrode lead becomes the negative side of the circuit, produce the greatest deposition rate. Okay? On TIG, it's a small weld, so we're not putting as much material down on TIG alone. Now, there's other welding electrodes that we can use DC electrode negative, and we do put a large amount of material down as well. Okay? As you can see here, workpiece, this is our ground, negative, here's our positive terminal, electrode positive, workpiece is negative, vice versa, negative, and this is the positive side. Okay? Polarity, we kind of discussed that. Let's go back to the book and cover it real quick. Page 341, chapter 13, right-hand column, bottom paragraph, under polarity. In a DC circuit, the current always flows in one direction. The electron theory has the current flow from negative to positive. Now that is a very important bullet point. Okay, I guarantee you're probably going to see that somewhere throughout this program. And it's also important to understand. As a child, I always remember thinking it went from positive to negative. But as I started getting more and more into the trades and electrical and so forth, you actually learn that it goes from negative to positive, especially in a direct current position. Or in a direct current polarity, I'm sorry. I want you to read through that chapter. Let's go over to page 342. Top left-hand column, or not top, but the left-hand column, first paragraph. It starts out of the circuit, and it shows figure 13-4. The electrode positive will produce the deepest penetrating weld. It's a bolded point. While at a given amperage, electrode negative will produce the shallowest penetration, but the greatest deposition rate. Next paragraph, the bolded point. Type of electrode determines the kind of polarity necessary for operation. In AC welding, there's no chance of choice of polarity since the circuit is alternatively positive and negative, first on one side and then on the other. Next paragraph, arc length and arc voltage. So it brings us to our PowerPoint here. A fairly short arc is necessary for SMAW. A short arc permits the heat to be concentrated on the work and is more stable since it reduces the effective arc flow. Okay. Next column, right-hand column, top paragraph. I want you to highlight that paragraph and read through it. You know, the main thing we're going to talk about here is the long arc. The arc is unstable. The weld shows poor fusion, porosity. Length of the arc depends on the type and the size of the electrode. Again, general rule of thumb is we never want our arc to be longer than the diameter of the rod. So if we're running 8 1/8" electrode, we're looking at flux coating now as well. 1/8" 7018, we're roughly 3/16. We don't want our arc length to be much longer than that. Sorry. And again, there's a little bit of fine tuning in there that you can do, but that's the general rule of thumb. It never wants to be greater than the diameter of the electrode. Okay? Page 342 out of the book. I want you to go to the right-hand column, very bottom paragraph. It starts out, good welders can tell if they are welding with the proper arc length by the appearance of the metal transfer in the weld pool and by listening to the sound of the arc. This is very true. However, after the first couple courses, there are times to where you can see it, you can still hear it. If I'm doing an open root weld, a lot of times I'll pull my hearing protection out to make sure I can hear the echo within the weld or behind the groove plate as well. You know, we have some of the most amazing senses built into our body. Most of us do. Some of us are not as fortunate. However, if we have the ability, make sure we use our sight, our sound, and touch. Okay? You can feel the amount of pressure coming back and forth on this, especially the more you relax. Sometimes you'll need to push in harder. You can see the weld puddle, you can see what's going on, and you can also hear the difference a lot of times of penetration, as the echo will change quite often when you're welding. As you start welding, you'll understand exactly what I mean when you hear it. A lot of people say it sounds like frying bacon. I don't know if I compare it to that. It's just a totally different sound. But you do want a nice, even, consistent sound. I don't think that sound alone should be the only thing you're looking at, or only sense that you're looking at. You need to make sure you're also seeing it as well. Okay? So the arc voltage increases with arc length, amperage decreases. Go to the book. I want to go to page 343, chapter 13. Left hand top column underneath the paragraph titled Arc Blow. The welding student will find arc blow a disturbing feature of arc welding. Arc blow is the swerving of an electric arc from its normal path because of magnetic forces. It may be likened to a number of magnets all pulling at a ball of steel. The ball will waver between the different magnets and will finally be attracted toward the magnet with the strongest pull. Arc blow is especially noticeable when welding with large diameter electrodes. Excessive arc blow may cause lack of fusion, porosity, and excessive spatter. Arc blow may be controlled somewhat by moving the work clamp to another location and by changing the position of the electrode. We covered this, I believe, in a previous chapter as well. Current value, type and size of the electrode to begin with. Sometimes you'll get, if you're trying a new rod, especially with today's technology, it's important to look up, if you get say Arctaloy 55, it's a nickel rod.